Yes, hello everyone, and welcome to the Evoluon. Welcome to all of you in the room here, as well as to a welcome to all of you online. You have come to the car reveal of the 8th team of TU Ecomotive. Us as TU Ecomotive, we're a student team, and we're a team, before I introduce the car, that consists of 28 students. These 28 students have worked very hard last year on our newest car. And we work in a group that's multidisciplinary. So that means that we have students from all different types of studies. I myself come from sustainable innovation. And excuse me, I forgot to announce myself. I'm Stijn, I'm the host. And all the others in the room come from various studies, like mechanical engineering, industrial engineering, and computer science, as well as many other studies. In our team, we work both part-time, so besides our studies, as well as full-time, which means we take a full-on gap year to work on this project. And as I mentioned before, we are the 8th team of TU Ecomotive. That means that as a student team, we already have quite a big history that I would like to show you in our next slide. We've already built 7 different vehicles. In the foyer upstairs, you've likely already seen the first 3, which are Lina, our bio-based vehicle, Luca, our car that embraces waste and is made from recycled materials and waste, as well as ZEM, our car that strives to be as CO2 neutral as possible, ZEM standing for Zero Emission Mobility. Before these 3 cars, we also built Penny, Isa, and Nova, which all participated in the Shell Ecomarathon. Those are at the top row, and the Shell Ecomarathon is really a race about fuel efficiency. And we made Noah, the world's first circular car. All of these cars have been made with one common goal. And this goal is really to create innovative concept cars through innovation and collaboration. And what we do with this is, together by collaborating within a team, as well as with all of you, with our partners, we work together to come up with fun ideas to tackle the problems that are in our current age in mobility. And we do this because our greater vision is really to create a future where we strive for climate-positive mobility that is accessible to everyone. And this is really where our year started. Because what does climate-positive mobility mean, and how do we get one step closer to this? Well, climate-positive mobility to us means that a car contributes more to the climate than it actually takes from the climate. And how we looked at this is we really looked at this from an emission standpoint. So ZEM already told us something. Namely, that a car has emissions in 3 separate life phases. It's not solely this middle one, the driving and the usage phase, but it's really all about the production phase, the driving phase, as well as its end of life. It's about the whole life cycle. And with our legacy, we've already shown that we can do some fun things with this. For example, we've shown with ZEM that with its carbon capture filter, we can actually vacuum clean the air of CO2. We can actually capture carbon whilst driving. And with, for example, Noah, but also other cars of our legacy, we have really looked at the end of life and shown that we can make cars circular, and we can actually reduce emissions in the end of life phase. But there's one step missing. We haven't yet fully looked at the production phase. And that's where our year started. Can we do something with this production phase? Because electric vehicles at this point have most of their emissions within this phase. Well, I think we can, and let me show you by giving you an example. Let's take ZEM as an example. We have 3 life phases: production, drive, and end of life. And ZEM already has shown that ZEM takes about 30 tons of CO2 to make. And an average car is actually used for about 20 years. So from the moment it's produced till the moment it's being recycled, or it's at its end of life, it takes about 20 years. Now, we really want to look at this production phase, but we said, let's take it in a different way, because we can't really change the way car manufacturers produce their cars. We can't really do much about that. But we can do something about this driving phase. Because what if we now build the same type of car with this 30 tons of CO2, but we actually double its lifetime? So we actually make sure that it can drive for way longer. Let's say double, then relatively speaking, this would mean that all of your emissions are spread out over a way longer time, and therefore you can make great impacts on the sustainability of the mobility sector. and we can get this one step closer to climate positive mobility. Well, if you want to drive a car for a longer while, what you have to do, in our case, is you have to look at material optimization. How can we use our materials as well as possible? And this is where we come to what I would like to call an interesting sustainability dilemma, because what you really see is two types of products. Namely, you have products that you use for a short time and products that you use for a very long time. Let me give you two examples. For the short time, you have products like this cup. This is a cup that you can use, maybe you bring it to a picnic, and what happens is you use this cup for a few times, but after a while, you'll have to throw it away. And at this point, from a sustainability point of view, you will want to make this cup as recyclable as possible. It's a product that you use for a short while, so you need to be able to recycle it. Other products are really used for a very long time. Let's, for example, take your house. To make a house as sustainable as possible, you really want to make sure that it stays there for as long as possible. Most of its emissions are during the production phase, and as soon as the house is built, you actually want your house to stay there. So your material choice would lead to materials that actually last for a very long time. Okay, so these are examples that don't really transfer to mobility, right? It's nothing to do with mobility, but let's transfer this to electric vehicles. Because you see the same happening within parts of your electric vehicle. On the one hand, on the left side, you have your short usage. On the right side, you have your long usage. Think of your exterior, your dashboard, and your chairs. These are parts in a car that are susceptible to change. After a few years, maybe 5, maybe 10, your exterior of your car can look outdated. You will want a new car. The same happens for your dashboard. And with your dashboard, it can even be more drastic, because in 10 years' time, the whole application and everything that's on your dashboard can change. The actual safety features and the luxury features. And finally, stuff like your interior, for example, your chairs, are also susceptible to this change. You don't want to drive around in a car that's very, very old. And now here comes an interesting part with the electric vehicles, because what if you look at some other components in this car? What if you look at the motor, the battery, and the chassis being the structural frame of the car? Well, now you may be thinking, Stijn, batteries don't last that long. That's something we all should know. Well, there's actually a shift in the automotive sector. Tesla is now designing batteries that can actually last up to 1 million miles, which roughly calculates to 80 years of usage. Then you see the split happening, because 80 years of using your batteries and other electric systems is way longer than you would want to keep your car from the exterior point of view, from your dashboard or from your chairs. And the same holds for your chassis. This is also a component in your car that you can keep for a way longer time than your average car. Okay, so now we have this split within two groups. But how does this look in a car itself? Let's place them on the logical spot within a car. What you now see happening is we took our conventional car, and you actually see that the motors, the batteries, and the structural frame are always located more on the lower side of your vehicle. Right? That's where an electric car has its batteries, has its motors. And what you also see happening is that the exterior, the chairs, and the dashboard are actually located at the upper side of the car. And this is where the innovative thought came into our heads. What if we structurally redesign these vehicles? What if we use the fact that we can have two separate sustainability groups, and we can actually change the way we use these materials? So what if we separate the two into two different parts, namely a durable bottom that actually makes sure these materials last as long as possible, because the materials ask for it, the products ask for it. And we take the upper part of the car and we make sure this can be used for 20 years, but afterwards it can be recycled and we can put on a new top. Therefore, we take the best of both worlds and actually make a car that can way outlast the average car. Well, I think personally this is a really cool idea, but I think we have to put it to the test, because maybe there's a reason why this isn't already on the roads. And for this, I think it's important to answer a few questions. Would this benefit us as consumers? Car manufacturers, would they want to see this? And most importantly, would it actually impact the climate in such a way as I already as already stated? Well, for this, I would like to ask a new speaker to the stage. Please give it up for our business manager, Hugo.
Yes, thank you. So, wow, what an amazing concept. But how would this car work in its environment? How can we use such a car in a way that is actually practical? And what are the main challenges that we face right now when we look at how cars are being used right now? I would like to give you a few perspectives. And as Stijn mentioned, the first one, the consumer perspective, has three major things. As a consumer, as a user of a car, you want your car to be safe. You want your car to be comfortable, and you want your car to be somewhat aesthetically pleasing. And when we look at these three things, and we think about an older car, let's say a car from the 1980s, and you look at safety, you can see perhaps your crumble zone is not that good. You don't have sensors on your car, so my model will probably bump into other cars. In terms of comfort, your AC is probably not in the car. You have maybe a cracky radio. And in terms of design, it's just an old blocky thing, which is really not up to modern design standards. So within this business case that we're looking at, we have to think about how we can make sure that these three things are incorporated in our concept to make sure it keeps being attractive to the consumer. But of course, there's also another side of the spectrum, and this is the car manufacturer. And currently, the car manufacturer builds cars, and once they sell a car, they earn money. So the more cars they build, the more money they earn. So in some way, they are also incentivized to make sure that at some point the cars they sell degrade and are in need of replacement, because in that way they can keep selling more and more cars. So within our business case, we also have to look at a way to make sure that the car manufacturer is incentivized not only to produce cars, but also to make sure they extract the maximum value out of a single car instead of manufacturing as many cars as possible. And this leads me to a few trends. And the first one, I think, is quite obvious, and that's an increase in electric vehicles. Some of you might have even driven here in an electric car. I know some partners have an electric car, so some people here definitely do have one. But the interesting thing that Stijn mentioned about electric cars is that the main emissions are in the production phase. So let's do something with that. And of these cars, 61% of all new cars is actually being bought by lease companies. So this is a trend that's only rising over time, but you are not buying your cars yourself anymore. Lease companies are buying your cars and you are paying a monthly fee. And this is changing rapidly. So with this in mind, we actually also started looking at our business case. And this is where one of our partners came in and helped us out. And this partner is Toyota Lauman Financial Services. And together with them, we developed this business case to make sure our actual numbers will be validated and we can actually say something that makes sense. And before I go into that, I want to dig into one more business trend that I find very interesting, which is supply chain integration. And for those of you who don't know what a supply chain is, this is basically the process from a resource to an end product. And all the companies that are involved in getting this resource to an end product are part of the supply chain. And within these supply chains, you can see that companies are starting to work together more, sharing information, and this is all with the goal of extracting the maximum value out of the resource that will be turned into an end product. And this is also happening within the automotive industry. But without further ado, let's dig into the lease concept that we have. And I want to show you how leasing works right now, because otherwise we don't have a reference. So leasing is actually quite simple. You have a lease company that finances a car, and you have a user that pays a monthly fee to make sure they can drive this car. This is usually done for a period of 4 to 5 years, and afterwards this car is handed in back to the lease company, and the lease company will sell this car off as a second-hand vehicle. Well, we wouldn't be Ecomotive if we wouldn't be slightly more ambitious than using this car for 5 years, so we try to extend this life cycle. So let's set up some game rules for our concept. Let's take a mid-range EV And let's make this car last for 40 years. So this, as Stijn mentioned, is twice the amount of a normal car. And just like Stijn mentioned as well, we will have this long-lasting bottom and this swappable top. And within these life cycles, you will have the bottom, which will be lasting for 40 years, and will have big maintenance after 20 years. And this is also the point where your top will be swapped for a new one, and this top will be, in turn, upgraded every 5 years. So, how does this work in practice? Well, let me give you a timeline. So, you start from year 0. Just like any other car this lease company has bought before, and any other car that you have driven before, you just buy a new car. You will use this car for 5 years, and after 5 years, instead of handing it in and selling it off as a second-hand vehicle, the lease company starts upgrading this car to make this car more attractive to the consumer. This continues on until year 20, and at that point, we will swap the top. And why do we do this? Well, after 20 years, we can swap this top and integrate all new features to make this car basically as new. And it will continue on for another 20 years. And after this point, within our business case, it will end, but perhaps we can even extend this life cycle to, let's say, 50, 60, or even 80 years. Well, this is all nice and all, but we still have other cars on the market. So how does our car compare to competitors? Well, we took some mid-range EVs and we calculated the average monthly cost of this EV. And this averages out on around about 653 euros. And we did some calculations with this lease company as well, and our cost price for the lease company came out at 619 euros, which is actually quite close to the commercial leasing price. So the first 5 years, the margins aren't that great. But something interesting happens after 5 years. Because, as you can see in this chart, after 5 years, the value of the car, or the monthly cost of this car, goes down. And this is all because of depreciation. In the first few years you use a car, the value of this car drops dramatically. And by extending the lifetime of this car and extending the leasing of this car, actual costs of your vehicle go down as well. And on the top part of the chart, you can see that the cost price, the projected cost price of this car, also slowly starts to decline. And then something else happens in year 20. And this is, of course, the point where the top will be swapped and the board will get an upgrade. So after that point, the car will be slightly more valuable, slightly more attractive, and this is what we want to do to make sure that the car keeps being attractive for this extended period of time. So the next 20 years will be just like the first 20 years, however, the margin will be slightly larger. And what will change? What will change for you? What will change for the car manufacturer? Well, from the consumer, you will have access to cheaper cars. These older cars will cost the lease company less, and therefore they are able to give the cars or offer the cars to the consumer at a lower price. And something else happens, because these older cars are more sustainable, because you are incentivized to use these older cars which are cheaper, and for the consumer this car is always being kept up to date. So these older cars are also still attractive. And when we look at the car manufacturer, you can actually see that supply chain integration will be a big part of this. Toyota Lauman Financial Services is actually a great example of this. It's 50% owned by Toyota, 50% owned by Lauman, which is a traditional lease company. And in this way, Toyota can actually benefit from the profits after selling this car. So they extract more value out of this car. And even when you extend this for a 40-year period, this only increases. And the last point that happens for the car manufacturer is that they get increased customer loyalty. Because once you buy a car and it will last for 40 or 60 or 80 years, you still need spare parts. And this car being sold needs those spare cars to come from the car manufacturer. So over this period, you will get revenue from spare parts and also from leasing this car for an extended period of time. Well, this is all nice and all, but we wouldn't be Ecomotive if we weren't talking about our most important stakeholder, which is, of course, our planet. Before we dive into this, I first want to give you some numbers about the European automotive sector. In 2022, the European automotive sector produced 10.9 million cars. And the production of these cars is equivalent to 294 megatons of CO2. And we did some calculations within our sustainability squad, and we calculated what the impact of our concept would be on this market. And we came to the whopping number of 109 megatons each year. But this sounds like big numbers, but what does it actually mean? Well, if we would use this car for 40 years, in the way that I just mentioned, you will actually save the equivalent of what Belgium emits within a year. But Stijn mentioned something else. We wouldn't be Ecomotive, we wouldn't be daring the industry if we took it a little further. So let's take 60 years and let's see what happens then. Well, then your emission reduction on a yearly basis grows to 145 megatons, which is roughly equivalent to what the Netherlands emits within a year. So from a business perspective, it gets my seal of approval. I think this will work, but there are probably still some technical thingamajiggies that have to be sorted out because it still has to last for 60 years. But that's not my piece of cake. So I give it over to Stijn, and he probably can bring somebody else on stage that knows a bit more about this. Thank you.
Yes, thank you very much, Hugo. What a great story. We actually have a concept that works for us as consumers. We can drive more sustainable whilst keeping our same car. It works for manufacturers. And finally, we can save upwards of 100 megatons of CO2, the equivalent of Belgium, even if we only use it for 40 years. Well, I say even if we use it for only 40 years, we still have to build this car, because we as TU Ecomotive want to actually dare the industry, and having a cool idea, having a nice business case, doesn't do it for us. You of course see these objects beside me. We are going to build this thing. And together with the whole technical team, for the last 10 months, we've really tried to solve all the technical issues involved in such a structure, because there's an actual reason why we don't already see these cars on the road, right? To actually answer all these issues and to answer all these challenges, I would like to call a new person on stage, which is our technical manager, Victor.
Yes, thank you, Stijn. We still have a technical part to solve. And for the technical side, I would first like to go back to Stijn's problem statement. So, of course, we wanted to make a car, and then we want to take the top part of that car, and then we want to be able to swap that. But let's look at what this means technically. The specifics are simple. At the top part, we have the exterior of the car, we have the interior of the car, so the inside of the car. Furthermore, we also have some safety features. Think about an airbag, your cameras, some sensors, etc. And finally, very important in the top part are some electronics. Then, in the bottom part, we have our electric motors, we have our batteries, we have some more electronics, and finally, we have vehicle dynamics. Vehicle dynamics are the part of your car that can steer, that can brake, and your suspension that damps your car whilst you're driving over the road. Now that we have this, of course, there are 3 big challenges to this. First of all, we need to structurally integrate these 2 parts, that they do not come apart and that all the forces act in the right way. Secondly, we have some electrical integration. And finally, we have something else, namely the braking and the steering. To note here, your steering wheel would be inside of the car at the top part, as well as your brake pedal and your handbrake, but the wheels, which will turn and which will brake, are in the bottom part of the car. So there's also some issues here. Now, if I were to say, go to a car manufacturer, they would simply say, you cannot make this. This is not possible, it's not safe, we cannot produce it, it doesn't follow regulations, etc. That's a bummer, but maybe we can. We are a student team. That means we can iterate a lot quicker. We are 5 steps ahead of the industry, and we are using cutting-edge technologies together with our partners to make the impossible possible. Furthermore, we can skip some of the outdated regulations that do not fit in our concept. And something that's also important is the industry is already doing something similar, but really in the production phase. They are using what's called an EV modular skateboard, where they build just the bottom of the car for a few of their models, and then they place a different model on top. But the difference here is that they only do this in their factories, and once the car leaves, it is fixed, and you cannot swap that top. With that being said, I would like to show a fraction of the hard work we put in, and after that, I would like to reveal the durable bottom. Look at that, the durable bottom from ETERNA. I think it looks really good. And of course, there are the things I mentioned earlier. So in the front, we have our vehicle dynamics, steering system, suspension system. In the middle, we have our batteries. In the rear, we have the motors. And all the way through, we have a bunch of electronics. But of course, there were some challenges. So let's look at those. Here is a visual render to help me explain it to you. The first problem we had, that was the integration. Okay, so what we did is we built this bottom part. It's a so-called ladder frame, but we need something on top of that. And for that, we designed something that we call the top frame. And the top frame is really the thing that houses everything on the top. The important part here is to notice the 3 connection pieces. So there in the front there's 1, and in the rear there's also 2. And now the idea is that this bottom part you can really put in the category that lasts a long time, and the top part you can put in the category that lasts a shorter amount of time. And the idea is then that if it's lasts a shorter amount of time, you do not need all of the strength, so you can make it a lot cheaper, and your CO2 emissions will be lowered. And then because of those 3 connection pieces, the bottom part can be strong. It can take all of the hits from the road, and then they don't travel through to the top part. Okay, then we can place this onto our durable bottom. Then we have another issue, and that was the electrical integration. We solved that actually quite simple. What we used is we used these big electrical connectors, similar to what you might see when two trains are connecting. We have one in the front, and we have one in the back. And then when you swap your top, you can plug these electrical connectors in. Cool. Then, after that, we can get back to our top frame and our board, and then we can look at what will happen when we try to attach the inside, the interior of the car. And then, if you remember, we had a problem where our steering wheel and our brake pedals were supposed to be in the top part of the car, but our wheels are in the bottom part of the car. Let's first look at the braking. So how a braking works in a normal car is you have your brake pedal, and then you have hydraulic lines running through your wheels, and then if you pump or press your brake pedal, the pressure in the hydraulic lines goes up, and that makes your wheels stop. But of course, if you want to take off your top, you need to remove this hydraulic connection, and there is a lot of issues with it. Besides this, your braking is a very, very safety critical part of your car. You do not want to mess with that, and that should be the last thing that fails. But as you might notice, the brake pedals are in the bottom. So what we did is we integrated the brake pedals in the bottom, and as well as the handbrake. All right. But for the steering, we decided to do something different, and we wanted to look at what we could do. To explain what we did, I first need to explain how a steering system normally works. So here you have it, very simple. In the top part, you have your steering wheel, in the bottom, your wheels, and then in between, there's something we call the rack and pinion. And the basic idea is, when you grab your steering wheel and you turn it like this, the rod in between moves, the gear turns, and your rack and pinion will turn from left to right. Very cool. But if we have our steering wheel in the top, we have our wheels in the bottom, there's a physical connection there. And how we solve that is by actually using the electrical connectors I showed earlier. We removed the physical rod, and in place we placed a physical or electronical connection. How we did that is by using a sensor. So what we do in the top, we have a sensor which measures the angle of your steering wheel, that when you turn it to the left, it can read, hey, I'm turning to the left. And then in the bottom part, there is a motor close to your rack and pinion that actually mimics this movement. That means if I'm just sitting in the car, steer to the left, my motor can mimic that movement and steer the whole rack and pinion to the left. All right, then this was our car, remember, and then we only have an exterior. But I'll leave that reveal for later. So I think for now, we have all of the technical things out of the way, and I'm gonna pass it back to Stijn.
Thank you very much, Victor. I think we've already almost come to the ending of our show. To shortly recap, we've seen our dream to make cars last for a longer time and make this great impact. We've solved our business case that showcased that this is actually a viable idea to also implement in the real world. And finally, Victor gave us the first glimpses of our durable bottom that can actually make our dream into reality. While all of this is done by us as a team with our hard work, but we of course couldn't have done this without all of our partners. So I really want to take this moment to say a big thank you to all of our partners that helped us. Without your knowledge, your resources, and your support, we as a team couldn't have done this. So really from the bottom of our hearts, me as well as the whole team, thank you very much. And before we actually get to this grand closing, I already said we want to make a positive social impact. So in exactly 3 weeks, the team and ETERNA, the car, will go on a full tour through Europe. We'll start in Nemo, in Amsterdam, which is the museum, where we'll talk to international and national press and make sure everyone knows about our story. After which, we've really chosen Europe because we want to go to the car manufacturers. We want to dare the industry. So we'll go to Germany, to Ford, and we'll go to Italy, to Milan, to Ferrari, to showcase our story. And later on, we'll go back upwards to Munich to go to the IAA Mobility Exhibition. For those of you that don't know, the IAA is the biggest mobility fair in Europe, and we'll be present there for the whole week to actually showcase ETERNA, our car. Then finally, we'll go to France to visit some universities, to end up in Brussels, where we'll actually showcase to the European politicians and to the European politics that this can be implemented on a more global scale and on a more bigger scale, and then we can reveal our concept. Well, we've now come to the final closing of the show. We of course already have this durable bottom, but this bottom wouldn't be anything without its top. So you will be the first to witness live on stage how we give ETERNA its top. All of this to complete our final concept car, ETERNA, the car that lasts a lifetime. What you now see happening is you actually see the structural frame that Victor talked about being connected to the bottom, both at the front as well as with the two connection pieces at the rear. Yes, and of course we want to see an exterior, so the first body panels are arriving, starting at the rear of the car. During this you also see the big electronics being connected, like Victor talked about. This is the point where the shoulders get into the room. The shoulders are at the rear of the car and they are placed over the rear wheels. Now, as you look to your right, you see the main attraction of ETERNA entering the room. It's the roof. And the roof has a clear leaf pattern because our design is fully inspired by nature. This leaf pattern you will see all across our vehicle. We slowly start moving to the front of the car as the windscreen is now arriving on stage. Now that the rear is finished, we can also really start implementing the interior of ETERNA. Slowly but steady, the car is getting more of its final shape as the front is entering the stage and we move on to the final pieces of the puzzle. Whilst the front is being attached, you see the chairs arriving, which clearly have this leaf pattern that I talked about before. These chairs also nicely show the recyclability of the top since they're fully designed for disassembly. Yes, the wheel wells are slowly being placed over the front tires as the doors start arriving on stage. We are almost there at the final looks of ETERNA. There it comes, the final piece of the puzzle as the hood is arriving on stage. We are almost ready to witness the first full looks of ETERNA. There it goes, the hood is now connected as it's time for Victor to come onto stage. Victor, step into the car, let the lights turn out, because it's time to witness the first looks of ETERNA. There it is, ladies and gentlemen, this is ETERNA, the car. This is it, ETERNA, the car that lasts a lifetime. Over the past year, we've worked very hard on this, and as we have come to the final end, to the end of our presentation, we as a team would all love you to come have a look at our vehicle, come up to the stage, look at the car, and afterwards go to the foyer where we have our other cars, as well as augmented reality, in which you can actually swap tops on and off of the modular board. Thank you very much for your attention.